Okay, so yeah, today I'm going to be giving kind of an overview on web agents, where we stand currently with all this crazy hype and the day we live in nowadays. So yeah, so I'm currently at Meta, a visiting researcher on the Llama Agents team, and I'm an incoming PhD student at CMU. So first, let me define what web agents are, and specifically what are LLM web agents. So web agents are autonomous actors that can take intended actions on the internet. And the difference with LLM agents is LLM web agents are web agents that incorporate LLMs as a decision maker. So LLMs that can take input and output actions on the internet and interact with the internet. And these LLMs have allowed web agents to expand from traditional automated processes, because they're able to interact and reason and think and break out of just like, an automated script. And another question I get a lot is, why do we even care about this? So why, we don't have this in the first place? Why do we want them? So many of our tasks are performed on the computer and the internet. And I think all of us can probably agree that we waste a lot of time doing menial tasks. Stuff like, responding to emails or making sure you get this reminder. And essentially, like when I'm at school, when I'm a teaching assistant, I have to log hours every week. Or if I want to send out a tweet, I forgot. If I just had a web agent do all these things for me, that would be really nice, right? So this would save a lot of time, and I think it would be very useful. So a historical use case of web agents before all the LLM stuff was just scalping bots. So people would have these scripts or just code that runs and checks all the time. So when you couldn't get the Taylor Swift tickets, it's probably because a bunch of people had these bots, these traditional web agents where they just launched a script and it just checked and it immediately checked out before you as a human could even reload the page. And this also happens for shoes and anything. That I think one of my buddies has one for SNL. So SNL has, like, in the morning, they have this website where you can easily game the system and bot it, right? So stuff like that. And people have been doing this for a while. So I want to talk about one modern day example. It's called Utori AI. It's a startup. And so they use LLM web agents. So this is how you can different a little bit.
Tasks online. With Scouts, you can have agents monitor the web for anything you care about. My friend wants me to book a tennis court, but sometimes they can be hard to find. Instead, I can create a Scout to monitor for availability at my favorite tennis court. And Scouts notifies me when it finds one for Monday at 7:30. Say you're looking for new 2-bedroom apartment listings in your neighborhood. You can have Scouts monitor and notify you when they're available. If you want to track.
I didn't get paid to do this, by the way, but as you can see, it's able to search the internet and go through different websites and do summarizations. It's able to reason, essentially, things that LLMs can do that, traditionally, if you're just running a script where it's like, oh, just check Ticketmaster, or, I found this reservation for only one website. So these previous web agent, use cases were very brittle to change, and it's hard to scale, right? So with these LLMs, you're able to essentially, diversify and make it easier and have a more seamless web agent experience, which is why people are interested in investing in this and working on it.
Tasks online.
Okay, so yeah, another use case is deep research. So a lot of these companies like OpenAI, Google, and Perplexity have been using web agents, crawling the web to get information or find information for you. Right now, I'm visiting University of Waterloo, and I have no clue what I want to eat, right? So, and I don't want to go through the mess of going through Google Maps and going through reviews. So I just asked Perplexity, can you find the best Korean and Chinese restaurants to try for my trip to University of Waterloo this week? And it gives me all these, options. It's great. It gives me the sources. But in order to find these sources and crawl the web, it has to take these steps, right? So it crawls the web. It essentially goes to each source. It gathers the information, comes back, gives it to another large language model, which summarizes the information and gives it in the nice format that we had earlier. So these are two like really hot use cases right now, and I don't know if you guys would use them. I definitely do already. So I think the web agents have a place to stay. So as an academic, I'm going to give you guys kind of an overview or history through an academic lens. So, before the LLM craze, Andre Karpathy and Percy Liang, they actually had a paper called World of Bits, an open domain platform for web-based agents. So they kind of had this foresight. Those two people are very famous, obviously, and a good research taste. So they created a bunch of fake web or interaction environments. They're nothing like the real web, right, as you can see. But it was trying to train a model to mimic human behavior or expert behavior on the internet. And so this is before the GPT boom, and you can see that they're trying to use a CNN and concatenating with the text representation of the internet to output mouse positions. So this seems really hard in retrospect, but this is kind of why I think there wasn't necessarily a huge push for this. It was really hard before, or I guess not thought about until the LLM revolution. And so after GPT came out, people started thinking about different ways to apply these large language models. One thing that OpenAI did was is something called WebGPT. So they essentially taught the LLM to use a text-based web browser and fact-checked its basically its answers. So an issue was it was hallucinating way too much. And so, hey, can we go to the internet, teach you how to use the internet, train it to basically confirm this? So this is pretty interesting. Maybe they can use this in political debates. But this is kind of like, your V0 of deep research, right? Because your base LLM might not be able to give you real-time or accurate knowledge about, but what restaurants are good at Waterloo, right? So using the web, this was kind of one of the first renditions by OpenAI to do this. And so this led to a bunch of academic interest in creating evaluations for web agents, right? So for a short time, a lot of this was using text only. So as you guys know, GPT-4V came out in late 2023. So before that, it was still all text. And so a lot of people in academia came up with these simulators or static trajectories of the real internet. And so, yeah, I just want to give the credit here. This is like at Princeton, OSU, and CMU Graham Newbig. These people are like, if you are interested in any of this stuff, look up all of their work after. They have done a lot of work on this, more than I can cover in this talk. So mostly this was covering how LLMs can take in, HTML or textual representation of the web page, and given a task, can you predict the next step, right? So yeah, this was kind of the first three big papers in this area. And mainly what it did was it created an evaluation set and basically an agent harness for you to put in any LLM and evaluate its ability to input web page text and output the correct action. And then after, GPT-4V came out, this kind of opened the path for multimodality with web agents. So I think people realized, hey, like the HTML page is really cluttered, and I'm going to get into this later because I'm going to be talking about some of these papers. It's really cluttered. The context length is really short, and sometimes there's information in the visual input on the web page that you can't get from the HTML page. So for example, on the Reddit example here, like say I want to get to the example or get to the post with like the red strawberries, and then there's no red strawberries indication on the HTML at all, then you're not going to be able to do that. So these are a couple. So Visual Web Arena, I was on this paper with my coworker JY and my advisor Ruslan Salakhutdinov. They also produced OmniAct and C-Click. So these are all pretty seminal papers that I would advise anyone who's interested in the space to read about. ScreenSpot, which is the benchmark created by C-Click. This essentially is a benchmark is specifically designed to test an LLM's ability to do visual grounding. So it'll be like, hey, can you click on this button for me? And there's like a bunch of these observations that you want to try. And yeah, models are pretty bad. So if I didn't mention this before in the previous benchmarks too, all these academic evaluations have found that these LLMs are pretty bad at these things. And now currently we're expanding to different use cases. So the first couple benchmarks and works that came out in the last year or two were web-based and stuff like shopping or Reddit, very average human internet tasks. But now we're expanding to different use cases. So work arena. So this was testing how web agents are good at solving work tasks. The agent company, this tests how good LLM agents are on like using Google Drive and using an online Slack. And it's expanding even more to OS agents. So OS World is an example of this. Windows Agent Arena. So they're testing your LLM's ability to take over a computer, right? So can you do this in terminal? Can you find this file? And then Gaia was one of the seminal benchmarks for deep research. So that's the example I mentioned earlier with the Waterloo situation, and that tests your ability to basically go outside of your domain knowledge, go on the web, and answer a question. So now that I've gone this rant and spiel about all the different works that have been done and the progress that has been made, you want to ask, what are some core research problems, right, of web agents? What are people working on? Why don't the LLMs just perfectly know and understand what I want to do? So one of the first things is instruction following and grounded language interaction. So what does that mean? So for example, if you ask an LLM what's 2 + 2, or who was the first president of the United States, it's going to answer that very well because it's able to. This information exists in its training data. However, I don't know if you can anywhere on the web you can crawl and find input HTML page, output click element 42 or click this coordinate, right? That doesn't exist on the web. So since this doesn't exist in a lot of these state-of-the-art large language models, it's going to be worse at this than a lot of other tasks, right? So when these academic labs first started checking or evaluating if these LLMs are able to do this, there was some hand cherry-picked examples like, oh man, like it can find the red shirt or it can check out for me. But most of the time, it's really bad, right? It gets stuck in loops, it hallucinates, it says nonsense. So to preface, these web agents are pretty bad. Another core research problem is multimodal web agents, so aligning input and output across image and text. So if the LLM knows the plan, if it's able to reason correctly, it says, hey, if I want to buy a swimming pool for my kid's birthday party, it knows to go, hey, I want to go to Amazon.com, but it maybe clicks the wrong element on the page. It doesn't know how to ground the exact element. These are issues that exist in current large language models. And another interesting topic I'll talk about today is memory. So can web agents infer from experience? So can they learn from user history? What the user likes to do? Is there a certain way they like to do things? Can they learn from expert demonstrations? So if a user has a certain workflow, can they repeat this successfully? And so this kind of takes on things from recommendation systems, also RPA, right? So there's a lot of work that has been done doing RPA to automate data entry, a lot of menial tasks. But can you get web agents to do this? Because LLMs are prone to hallucination or compounding error. So if you want to use them in these repetitive and automated logic calls, are they also able to reproduce this to a very high accuracy? So I'm going to start talking about some academic works I've been a part of to kind of elaborate on these research ideas. I'm not going to be able to get to everything, obviously, but yeah. So let's get started. So Web Arena, this was a paper that came out of CMU, and it's a simulated web benchmark. So what this basically did was they released 4 Docker images for 4 websites. And these are simulated websites. You can open them on your computer, and they're self-hosted, and they have data from real websites. And the team released about 800 tasks, right? So that means like go on the shopping website and find me a shirt that has Minnesota Vikings on it. Or as you can see here in the graphic, it's like, tell me how much I spent on the food purchase in March 2023 on my e-commerce site. Or go to GitLab and go to the repository and tell me who the creator of the repository is. So 800 of these tasks, ranging from very short to very long. And we found that tasks are easy for humans, so around 80% of the tasks are doable by humans, zero shot. But for LLM agents, you suffer quite a bit. You get around 14%. So one thing is that WebArena tasks are designed to just use HTML code and text. So I'll get into that, what that means a little later. One thing you might be curious is, how do you evaluate these tasks? Obviously, you're not going to have humans check it or evaluate it every time. So we have execution-based evaluation. So we design functions, implement functions, or LLM-based judges to evaluate whether the final the final state or the trajectory was satisfactory. So one thing you can do is, hey, can you navigate to my listing of the white car and change the price to $25,000? So once the agent says it's done, you check the URL and see if the correct URL is there, or if the price on the page you extract it is what you want, right? So all the evaluation is automated, so you guys can go run with it, play with it, have fun. Yeah, so a couple of environment specifics. So a lot of these agentic evaluations and benchmarks are done in a POM DP environment, so a partially observable Markov decision process. So you give the agent a state, and then it's able to output an action within the action space, and it gets you to a new state. And then at the end, you have your reward function, which is what I just talked about. So the different type of states that are available are the screenshots, or the HTML, or the accessibility tree. And the different actions are essentially what you can do on a computer as a human. So click on an element, hover on an element, open a new tab, all of these things. So essentially you're inputting the HTML to the LLM agent, then it's able to output an action. So this led to some ideas about, hey, is HTML code enough information for these web agents when being used in the real web? And like I said, hey, if I want to go to that, if you want to click on the red beanie here, that might not exist in the HTML code. Or if I want to make slides for this site and say, hey, can you place that in the bottom right corner? Or can you put this image above the Carnegie Mellon University logo? It's not going to be able to do that with just the HTML code. It might be by accident or random, but it's going to be really hard. So we found that HTML is insufficient, right? So messy HTML and JavaScript have to usually be compressed for efficiency as well. So like I mentioned, context length is bad, right? Like the context length with HTML pages easily fills up a lot of the effective context length. And the web is currently designed for human visual perception. And so, when you have these web agents that do the tasks you do, you want them to also be able to have all the information available when you do your workflows. So the next work that came after this was Visual WebArena. It's a visually grounded benchmark. So essentially, we took the same sites of WebArena, but we designed 900 new tasks that are visually grounded. So stuff like, hey, can you take me to the pink iPhone? Or you give the LLM the image of a posting and say, help me make a post selling this item, and price it at $10 cheaper. So every task was specifically handmade and crafted to be visually grounded. So you can't answer the question by just looking at the HTML or text. So like I said, this is the LLM and VLM agent framework. On the left is an example of the text-only agent I was talking about earlier. So they would just, essentially have access to this really long list of all the elements on a web page. And that is what the agent is given, and it's given an objective, and it's supposed to output, like, click on one of these elements, which is really cluttered. It's not intuitive. It's really hard. And one of the things we did was we created a VLM plus set of marks. So set of marks is when you draw bounding boxes over all the interactable elements. And we simply just give the visual language model the set of marks image and ask it to click on, one of these elements or do something with this web page. So what does this look like? So say you have your original web page of this fake Reddit website. You run set of marks on it, and it gives you a web page screenshot of all the interactable elements. You can also, if you want, include these set of marks elements as textual input and say, I'm trying to find this post, navigate to the comment section for it. This post obviously exists at the end of the web page. And so using the set of marks, bounding boxes and boxes or numbers, the VLM agent outputs click 31, which is the correct thing to get to the comment section. So this is kind of how the VLM agent setup works. And in this paper, we also found that, VLMs are still pretty bad at this stuff. And you do need multimodal and set of marks, and it doesn't help improve your performance, especially on tasks that are visually grounded. And realistically, humans wanting web agents are going to have visually grounded tasks. So it's still, a lot worse than human performance. Human performance was around 85%. So again, another work that highlights how bad all these models are at being web agents. Yeah, so a couple of takeaways from this paper were, the planning, it gets stuck in loops or undoes correct tasks even. Visual processing is an issue. It identifies the wrong item. It can't do spatial reasoning. So there's some tasks that are like, hey, can you, on this page, go click on the item that's to the left of the green toy. And it's not able to do to the left, to the right, the first row, second row, third row. And another thing is aligning language and vision and action prediction. So if the LLM, again, plans or reasons correctly, but it's not able to click on the right element, or it grounds the wrong box, that's also an error. And so modern LLM agents still lag far behind humans. And the long-term goal is to automate 90% of these computer tasks. So you need stronger vision language code models. You want search and planning and reasoning over long horizons. So this was, these were two benchmarks that came out of CMU I'm pretty familiar with, but a lot of the work that was being done around this time was just uncovering, hey, these capabilities don't exist. How can we incorporate them, especially in academia? You don't have like a buttload of compute, so you can't just try and collect this agent data. This is a lot of the errors that were found. And so this led to the research questions. We found all these issues with these agents and these LLMs, and how can we make them better? Can you have them learn from their own experience? And can you prompt them to do structured reasoning? Is there any way to make sure they don't hallucinate or cause these errors? So this is a paper I was a part of with Gabe Sarch and Katerina Frakiodaki at CMU and some collaborators at DeepMind. So the premise of this paper, let me get into it, was can web agents learn from experience, especially in these academic domains or environments where you have your hard-coded reward, so if you completed the task or not. So the way we set it up was using the VLM setup from Visual Web Arena. We ask it to do structured reasoning, so produce the abstracted state, decompose the task and sub-goals, and predict the state changes. So this is kind of, essentially prompting it to do some world model stuff. It's not great, but it does improve performance. And you're also giving it, K in context examples. So we thought, hey, can you, change, also the in context examples to be dynamic? So again, this is the human in the loop learning of reasoning actions. We thought, can you have humans teach these VLM agents, the correct way to do things or its own preferences? So what we did was we had this VLM agent, we prompt it, and then it completes an action, and then a human observer tells the agent if it's optimal or suboptimal. And this is all natural language. So when it tells if it's suboptimal or optimal, if it's suboptimal, you can just give it feedback saying, hey, you should sort by price instead of whatever action you did. you give this human feedback to the VLM, and it's actually able to just produce the revised reasoning and actions really well. It's able to do the correct thing just from natural language. And then you just do this loop until you collect, case successful trajectories from the human supervision. So after you do this, right, this is essentially what it looks like. You act in the environment, you get the success, and then you add it to your memory. And every time you have a success, essentially you add it to your memory. And so we did this on Visual Web Arena. We ran this iCal learning on 93 tasks on Visual Web Arena, which is a small subset of the total, of the total evaluation. And we found that, using learned data is, state of the art in visual web navigation. So there's about a 1.6 times difference in performance when you use iCal before. And then when you can also fine tune on these successful trajectories, which is, kind of an indicator that you can use human supervision or exploration to collect this fine-tuned SFT data. You fine-tune Quen 2, and it does 2.8 times better than the base Quen 2 model. And so one example we did was, showing the model how to book a table on OpenTable versus you just using the base GPT-4o model. So the base GPT-4o model just searches for Marcia, and it stops and says it has a reservation. And that's not exactly what you want. But all we did was we showed it, a couple examples of how to go to OpenTable, and then from this iCal learning experience, it's able to do exactly what you need, and find that there's no open tables. No reservations, even though GPT-4o said there were reservations. So this is simply an inference-only algorithm, and yeah, but if you want to, go collect training data for this instead, it's very possible. So, web agents are going to be working synonymously with humans, and having them in the loop to correct it, guide it, keep it for future experience, and having good memory of this is kind of, I think, important work that's going to be expanded on in the future. So yeah, there's evidence of goal-driven reasoning. So from the iCal memories, you have that clicking on the time link is incorrect because the date needs to be adjusted first to check availability. So from previous human experience, it's able to infer this and do all the correct reasoning. And when you have this structured reasoning that I talked about, where you do chain of thought and break it up into the world model principles, you're able to plan, predict the next state, and get a better revised action. And so this kind of pushed me into the idea of, how can web agents learn from experts effectively? And this led me to a paper I did last summer in Microsoft. It's called Video Web Arena. I bet you guys are probably getting tired of this name by now, but it's a video-based benchmark based off of Web Arena and Visual Web Arena. So 6 combined websites. So the Craigslist, Reddit, shopping website, Map, GitLab, and a commerce store. And so all agentic tasks will require video input. And so the motivation behind this was that my first couple days in Microsoft, I was getting set up with my computer, getting set up with Teams, and I was having so much trouble just navigating through the documentation instructions that were saying hey, just go to this section. I couldn't find it. And so I ended up just calling or Teamsing my boss and saying, can you explain this or show me how to do it? And his human expert demonstration in a matter of 5-10 seconds solved these issues that I wasn't able to figure out through text. So I thought about this was, hey, there's a lot of tutorial data on the internet, or there's a lot of expert demonstration. Humans learn a lot through expert demonstrations. LLM agents should be able to do it the same way. So all the agentic tasks in this benchmark require video input. And each task also has a question-answer pair to test if the model can retrieve the necessary information from the video. So I'll get into that later. So our VLM is essentially able to get the correct information and also act agentically to do the correct thing. So what we did here was we took the tasks in Web Arena and Visual Web Arena, and then these tasks are not all different. So we created 74 tutorials that encompass all that 1,641 tasks. And so this essentially leads to 1,641 tasks with tutorials and 400 new video-based agent tasks. So here's an example tutorial.
Hi, today I'm going to be showing how to check key stats on customer reviews and different reviews that have been made on separate products. So the first thing we're going to do is navigate to the marketing tab on the left-hand side. Then we'll click on all reviews, which is under user content. So from here, we're led to a table where we can query for different information. For example, if I want to look for reviews where the term good was mentioned, I will search good in the review. And then I can scroll through and look at all the different reviews that were made that mention good. So 39 records were found, and if I want to navigate to the next page of reviews, I'll click on the next page button on the right-hand side and continue along, and I can look at all the different reviews that have made.
So essentially, this 3-minute tutorial covers a bunch of tasks in the original Web Arena or Visual Web Arena suite, and for tasks, you're able to essentially know all the functionality required for a certain task through this video. So as a human, if you saw this tutorial and asked to do something on this website, even though you may have never seen it, and you probably haven't because it's a simulated website, you would be able to do the task that's required.
Hi, today I'm going to be showing
with this. So all our videos are open sourced. You can go find this YouTube channel. It was around 4 hours of videos, and ranging from 1 minute to 10 minutes. And so yeah, this is where all our tutorials are. And so here are some examples of tasks. So for example, a skill retention task is, if you have this tutorial, can you test an agent's ability to learn from this expert demonstration? So if the video tutorial is how to buy a cheapest or sort by the cheapest item on the shopping website, can you now buy the cheapest red blanket from Blanket & Throws after having the video? Another type of task is, testing if the agent's ability to retrieve specific information from a video. So think that, hey, I'm watching a TV show, and this person in the TV show is wearing a pair of shoes I like, or they're in a TV show and they're in this setting, or they're in France, or they're in Paris, and I want to know where that is. So can you test an agent's ability to retrieve specific information from a video and use it to complete a task? And a bunch of our tasks also have question answer pairs that test if the model can retrieve the video information necessary for the task. So can you follow all the repositories visited in the video, but can you also tell me what the names are of all the visited repositories? So this tests if the issue, basically you're able to test if the issue with the agent was, its ability to retrieve the information from the video, or if it can't act with the information. So we had a couple baseline agents here. One of them was a video agent, so taking the whole video in context for Gemini only. So this is kind of the example. You take the video or a video summary, or the video frames, and then you take the task, and then you input all these things, and then the LLM agent is able to output an action. And then so there's a video agent that was Gemini only. Video frame agent, you take in the frames in the video and the audio transcription. And a video summary agent. So you just take a summary of the video, you ask an LLM to summarize the video, or a PLM to summarize the video, and then you feed that summary in context. So all these things, I assume the video agent from Gemini is chopping up the video into frames and doing analysis that way. But that was just the way the input was given. So it was notable. And so this paper was interesting because you can see that human performance without a tutorial is worse than human performance with a tutorial. Another thing is that humans, you don't have to explore once you know what's where. So you can see that on Web Arena, you almost have the amount of steps per task. So if I don't have to go look for a category, or I don't know how this website works, and since I've seen the tutorial on the same suite of tasks, it's able to do it at a much higher rate, and also at a much faster rate as well. And this is also applying to Visual Web Arena. However, you can see that GPT-4o with no tutorial is better than GPT-4o with with a tutorial in context. So this paper tested the ability for these agents to take this large amount of information in context, and obviously it's not able to. It actually does worse with the tutorial. So when you have the summary agent, it performs worse, and when you have the frame agent, it performs much worse, especially on Visual Web Arena. So all these frames getting fed in, it's not able to really decipher what information is important. Similar to kind of like a needle in the haystack type of problem. So yeah, the models do not work intuitively as you would think so. So there's a couple failure modes from this paper. First was the long context failure. So current, VLM agents are not able to do, video grounding, especially while doing agent tasks. It's not able to multitask. A lot of humans can't either, so I guess that's not a big problem. But once you have all this extra information in your context, you have failure to follow instruction guidelines. And so, yeah, you have agent-specific failures as well. So noise from summary plan can lead to more than one action generated or no actions generated. Video frames and summaries do not capture visual aspect and video input necessary to complete tasks. So this is kind of similar to the Visual Web Arena stuff. And there's a lot of base LLM failures that have nothing to do with long context or agent-specific failures. So just incorrect planning, hallucination, can't ground the visual web page. And, this takes into future directions. So how should multimodal agents handle videos or long context information? Should you have, a pipeline that summarizes expert demonstrations or human behavior? And then that's given to the agent in a compressed manner. And how can you extract training data or important guidelines for completing tasks? Because I assume, if you have these videos online, say I'm interested in how to do Photoshop, there's, thousands of videos on YouTube on how to do everything in Photoshop. So could you possibly extract SFT or training data for these agents from these expert tutorials? And how can you do that? Is there an automated way to do that? And then you can really scale up training. So yeah, these are very fun and important questions that are yet to be explored. And yeah, so I'm gonna wrap up here because I want to leave a lot of time for Q&A because this is kind of an overview of web agents and where this field is going. And so I've covered a couple papers that I've worked on, an overview of where the field was heading and what's hot right now, and specifically the common failure modes and errors that come with web agents and what people have discovered and possible inspirations. So how can we improve these things? Can we prevent them from hallucinating and repeating actions? Is simply the issue to all these problems scaling agentic data in your training? And how do you do that? How do you create good data? How can you create better visual grounding and modality alignment? So making sure you're clicking the right bounding box, making sure you're prompting them all the right way. Should you use set of marks? Should you prompt it with the text image? All these different combinations. Again, should we use multi-agent systems? So I'm pretty sure, or I theorize that deep research uses a planning model to produce, or a reasoning model, sorry, to do the planning, and sends the web agents on their way, which get the information, and then you use your reasoning model to take the information from the web agents and deep research, and it's able to output it to you. So this is, you have a reasoning model and the different web agent models working in parallel. And so, yeah, should we use multi-agent systems? Because a lot of the academic work we've done is just, singular agent systems, which, show a lot, it makes it prone to weakness. And so how can we improve our evaluation systems? How can we better expand to non-verifiable domains? And since, a lot of the domains we've had in academia in the current available public benchmarks are, things that have hard-coded reward rules, and it's very specialized. So stuff like Work Arena or OS World or Web Arena, these are all kind of, sandboxed environments that kind of have a gap between the real internet. And so even being good on those environments does not necessarily mean you're going to be good at, being a general web agent. So how can we make sure that when we are working on these models, improving them, evaluating them, the signal from improvements in evaluation translate to real world use cases. So I don't know, if I was a company, Fortune 500 company, maybe I would just make a library for my own software or my own environments, and then just RL the crap out of it. But yeah, so there's a big gap between simulators and the real web. Another issue is making our evaluations reproducible. These LLMs, there's a lot of variance in the first place, and especially these sandbox environments can be a pain to set up as well. So there's this software called Browser Gym, which actually automates and puts everything together. So I would recommend checking that out if you want to evaluate or work on web agents. But yeah, this is kind of the current state of things. I kind of want to open up. I wanted to open up to Q&A earlier because I want to be kind of an open book about this, and worked on a lot of stuff. So I feel like this part, instead of me yabbering on about it, it'd be nice for people to ask questions and find out stuff. So I'm going to stop this here. So thanks for listening, and let's open up Q&A.
There are some questions in the chat, in the Q&A section.
Okay, I'm going to stop sharing. I can't view the Google Meet without, or I guess I can. Let me see.
So it's in the bottom right, meeting tools and Q&A.
Yeah, I see now. Meeting tools. Sorry, I wasn't able to see this. Okay, a lot of questions. This is okay. So good thing I left time. Are agents always task specific, or can a single agent do multiple tasks? Taking GPT example, can we enable deep research and web search? Does that mean we're employing 2 agents? So yeah, I think I just talked about this. Agents work better when they're task specific, because you got to think these agents are given a system prompt or an objective, and once you kind of spread that out, that can dilute the agent performance. So I think in deep research, you have a planning agent that plans what you should do. Like maybe an O1 or O3, and then you have specialized web nav models that I've probably been trained on doing these tasks. So I think in product use cases, people are spreading up the responsibility across multiple agents. What if any security measures are in place to stop agents from clicking malicious links, gathering information? How are these measures implemented and updated? Stuff from clicking, gathering information. So there's a couple papers on this. I didn't focus on it because I haven't worked in security. But there's a paper called Adversarial Attacks on Multimodal Agents. And that talks about how people can manipulate websites or do prompt injections. And there's a couple papers on this, but people are working on it. It's definitely less worked on than capabilities, though. I think everything in AI, I think security has taken kind of a backseat. I don't know if that's the right decision or not, but that's just kind of how the incentives work. So they're definitely, these measures exist. It's just less than I think capabilities currently. Thanks so much. Yeah. Are there any methods by which an agent can recognize it made a mistake and trace back its steps? If so, how is this typically done? If not, why is this important or not implemented? So yeah, this is kind of a thing people are working on. In my paper on the dynamic episodic memory prompting, you change the in-context examples based on successes or failures you've seen in the past. But one thing is that agents can't really correct their mistakes all the time. So it says, hey, buy me the cheapest ticket for this Taylor Swift concert, and then it clicks the wrong ticket, and it just keeps going. It doesn't really know to go all the way back and fix it. This is an issue that we've been seeing a lot. It is important for the agents to recognize their own mistakes. I just don't know if it exists in their base capabilities to do so. So there's a lot of work on this. So some websites have really long HTML. So is it passed on the context, or is it a clean or ragged approach? So you can either so works that people don't really do this anymore, but you can shorten the HTML by summarizing it, and you can also do rag, I guess, if it's really long. but that makes inference really slow. So again, this takes you to the principle of like, what are we using web agents for? It's to do like a lot of menial things very quickly. And so when you involve things like RAG or summarization and things that require, consecutive calls over and over time, it might take away from the main goal. Do you have a theoretical framework at the core of what you're doing, or is it a pure engineering task? You could say it's a pure engineering task, especially when you're working with inference-only methods. But a lot of the academic work in this space has been kind of, poking holes, like essentially doing like red teaming and figuring out what they're bad at. And so there is some theoretical framework. I can't disclose too much, but yeah, there's definitely some theoretical framework you can do. Any experimental node or code notebook. I think if you want to try this out, like get it involved, there's something called LangChain. That's like very basic. If you just look up LangChain, like Web Voyager demo, you should be able to try this out. Is the code for iCal open source? Yes, it is. I can probably link that, or Ahmad, if you can. There's a whole website for the paper. For iCal-like approach, why do you need LLM, VLM, and why not rule-based bots work? HTML is pretty static, right? Rule-based bots. What I'm talking about for rule-based bots is you're only working on one website, and you can't change the rules based on. I mean, I guess the issue of this is that if you have 800 tasks that are different, and you want to do rule-based bots for all of them, how long would that take you to code? A very long time, and then making sure it works as well. So compared to just prompting an LLM, right? So this goes back to the whole thing of why people went away, or why people want LLMs, driving the web agents versus just having just these automated logic calls. Do you use pre-trained LLM and VLM rules in iCal, or is it a new model from scratch? Yeah, we use pre-trained, OpenAI models, and then we also fine-tune Quen too as well. So we do not use new models from scratch. A lot of the work in academia, as I'm going to emphasize, is a lot of inference only because of compute. You're not getting as much compute in academia. How do you collect data because of security concerns? You create a browser extension which collects trajectories, both visual and HTML, JS events. Obviously, the data we collected for iCal to fine-tune our model was, off the author's personal computer. So it wasn't like no one was like, I wasn't gonna like sabotage my co-author or like hack into his computer. So, but this is an issue with collecting data. Collecting data is an issue, right? Because you don't want people you don't want people. You don't want to spy on people's computers or give up security issues. So I think, this is also why collecting data is really tough for agentic, especially web agent tasks. On skill retention results, where the first tutorial hurts performance for GP4 baseline, why isn't there a step count for the no tutorial setting? Let me go look at this. Oh, this was just, no tutorial was reported in a previous paper, and they did not report the steps. So that's why it's not reported. Okay, there's a question from Muhammad Ali. Do we need to go back to the drawing board in terms of rethinking LLMs and VLMs to actually reach the point where AI web agents have 90% accuracy? Is there any work being done where hardware integration is being done to make totally autonomous web agents? So this drawing board thing, for sure. I think people are reworking this to the day. Like every day, I think people are working on how do we create these systems, or do we want to train LLMs a certain way, or how can we, maybe assign tasks, or it's a very open-ended question. I don't think anyone's done really well at it. So yes, I think we do need to go back to the drawing board, especially with respect to the academic stuff. Is there any work being done where hardware integration is being done to make totally autonomous web agents? I assume so, just by making hardware better, that makes it better for totally autonomous web agents. I'm not sure if there's specific hardware integration for web agents. I would not be the source on that. When you said it does worse from 13 to 11.9%, is there an estimated variance to back up that these are actually different performances? So the sample size on this is like around 1,600 tasks. So the standard bar is not that much when the performance drops. But the main point for the performance dropping of the tutorial is that humans do better with the tutorial, and you see drops in performance with the tutorial for LLMs. Some websites, HTML changes over time when they redesign. How do you tackle the dynamic changing nature of websites? Again, another question that has not been solved. So I think that, man, how do you solve this? So again, you just got to make sure your agent is not brittle to changes in textual or visual input. So either that means scaling, or just getting your model to be robust enough to this. I don't know exactly how this will be done, or I cannot disclose. So that's where. Are there any prompting best practices for agents? Which prompts will they understand better? I think all of the Frontier Labs have had their system prompts leaked. So you can probably Google that somewhere. But it depends on what type of agent you're prompting for, or how many tasks you're giving it. So if you have a planner agent, or you just have an executioner agent that's just going through the internet, you're going to have different prompting prompting practices for sure. What kind of question would you pursue if you don't have a large compute resource in this domain? I would say a lot of academics, or just in general, you can work on showing results at small scale, or finding a problem that needs to be worked on, and showing that there's issues, and showing scale, like showing very small scale that you can fix it. So yeah, training is going to be pretty hard if you don't have compute. I will say that getting compute is not as hard as it was 2-3 years before with all these providers. But I would say find a problem that you're passionate about, or if there's something glaringly obvious to you that with web agents, oh, we should solve it. We should solve this, or it needs to be used like this. Another one's making an environment that doesn't really require much compute, right? So making one of these sandbox environments, or making a benchmark or an evaluation. Then and then showing small scale improvements. I think that can get a lot of traction, and people are really excited about these things. How does the agent get training for the video? We were not training from the video. That's future work maybe if you want to pursue. I haven't had time because I finished the work and then I applied for PhDs and went straight to Meta, so was not able to work on it too much. But again, yeah, like I said before, maybe you can extract SFT data, or extract prompting guidelines from these video tutorials and then give it to the agent. Maybe it's able to do a lot better. In web agents, what is the most effective way to make a web agent that gives the best results? That's pretty open-ended. I think I'll just answer it through other questions I have. How do the agents act on instructions to navigate through various web pages? Do they interact by clicking and typing like humans do? Yeah, so I went through the action space, right, with the agents, with the partially observable Markov decision process. So you have clicking and typing, opening a new tab. They have essentially the whole action space of humans. How can the agent detect if it's interacting with a phishing or spoof version of a legitimate website? Again, I don't know if it can. It depends on what agent you're talking about, but a lot of agents won't be able to because it's focused on the task at hand. And again, this kind of leads back to the point of when you're prompting the agent, it's pretty important to tell it what it's focused on because it's pretty bad at multitasking. But I assume, yeah, all these all the Frontier Labs, their system prompts include like little notes like this. So I assume they're able to, but not at a high level. Okay, with the change of the foundational paradigm and around information retrieval and the rise of chat-like interfaces, maybe the models will be more successful once there's a larger shift and we don't have to model for the older web experiments. There is a paper called Designing Internet for AI, or Designing Internet for Agents. And they brought this up, but it's like, is someone really going to change the internet, right? So that's kind of the questions. Like, do you think it's easier to just make the agents better, or do you think it's easier to change the web? I don't have an answer for that, but maybe you can ask yourself. Are there any thoughts on creating agent-friendly HTML and add that to pages? That sounds a lot easier than some of the changing the internet paradigm and thoughts people have. I know that some people, there's companies working on their own agentic browsers, right? I saw this in the news, but they're selling a product where they have their own browser that they work with, and that also makes it so that whenever they're running their agents in their own browser, all the representations are unified. So if you have an agent, it's really easy to control for variance across its performance when you know exactly what format the text representations are going to come in. So think about if I can redesign the HTML on my web browser, if I know exactly what screenshot size is going to be at every step. So there's definitely work on this. But to go back to the previous question, I don't know about changing Google for web agents. I don't think people will do that. I could be wrong though. What are your thoughts on Operator by OpenAI? What might be the underlying models? I think I've touched on this, just probably having a planner and then a web nav model. In the context of video web and similar benchmarks, how exactly does a multimodal model learn from watching a tutorial video? Since we usually use embeddings for text images, how does a model understand and extract meaningful steps or actions just from unstructured video content? So yeah, these are all great questions, and I hope you guys maybe pursue these while I'm in industry. So what I did was I fed in the video to the model. I didn't necessarily do any learning, partially because I really didn't have time. I submitted to a conference, which is kind of how these deadlines work, and it sucks. But these are interesting things. I think you can extract prompt guidelines maybe by summarizing the video in a structured manner. Maybe get, like I said, training data from video tutorials. And since you say you usually use embeddings for text or images, you can just extract images from the video and structure it into the embeddings you want. Or do we see web agents being live in production at scale? I think deep research, people are using web agents. Also, Utori, these startups are all using web agents. Considering how LLMs are now widely generating online content and how web agents routinely crawl and learn from web data, are there any safeguards or recognition systems in place to prevent a feedback loop where agents reconsume AI-generated content as primary learning material? I don't know. I would hope so, but I'm not part of any efforts where, I'm not on the inside of where web agents routinely crawl and learn. So this is a good question, but I don't know, and I hope there is. Someone said we were doing something similar. We take the focus.js events, and still we have a lot of mouse click type events. How do we post-process them so we can train the trajectories? It sounds pretty technical. I don't know. I would need more information from this. So a lot of mouse click type events. But I did explore a project at CMU that was trying to reverse engineer human activity, so like my own activity, and create SFT from that. But it was really tough. So don't know. How are current agents on tasks that require reasoning and planning through time? For example, scheduling tasks based on available information. What are some current approaches to make agents better at this? Through time. I'm going to interpret that as based on today's state or dynamic information like now. I think one could say that deep research crawls the web with respect to dynamic and time and stuff, but I don't know if you're not really booking action. I know Operator does, but all cloud computer use and Operator, all these computer use agents, there's all these security issues and stuff. So making the agents better at this, you want to have them aware to, previous user history and then the time context, but those are just the important points. But I don't know if I can say or confidently declare what are the best approaches to make agents better with respect to time. What about declarative languages to help with HTML parsing? Not sure what you mean by that. So I'm going to go to the next one. And I'm going to get to everyone's questions, so don't worry. Even if we're over time, I'll answer. Can you shed some light on ethical considerations with regards to LLM training and future directions in multimodal foundation models? Ethical considerations with regards to LLM training. Like agent training or future directions? Foundational models. I think, multimodal foundational models across the board, everyone are, like, you can just see from the open source models, people are including more agentic data. Like even the fund models are, their base models are very good. Not very good, of course, but they're much better at these web agent and computer agent tasks. And ethical considerations, I don't know what the other labs are doing, or I'm not in those meetings, so, but I assume these things are being talked about and are taken very seriously. Is having LLMs and VLMs directly interact with web pages the right way to go? I'm particularly wondering if folks have leveraged LLM's ability to generate code. It could script up subtasks or repetitive tasks. So there is another paper called Beyond Browsing, which has the agent not interact with the web page itself, but interact through APIs and codes APIs. So this is an approach being handled for sure. One thing is that, is this more generalizable to different websites by interacting with web pages through APIs or coding rather than just clicking? And especially if you want to scale data, or like data collection is easier to scale data collection with code generation on, these web interactions or just humans collecting data. Are these agents trained for solving tasks? If we tell the agent to complete guidelines or set to follow them, it won't be autonomous. If there's a way to automate the complete guidelines, right? So if you're able to, have this internet crawler that finds a tutorial for exactly what you want to do, it's able to autonomously get these guidelines, or say the agent learns to self-verify and complete tasks, and it's able to keep those guidelines somewhere in its memory, this would be autonomous. And what are the key benefits and challenges of implementing web agents, especially in e-commerce, and how can they be used to enhance customer experience and improve business outcomes? I guess the key benefits is like you don't waste time. I mean, I don't know. I do like shopping though, so I don't know if I would personally use web agents for shopping, but they can do things like proactive recommendations, and also just like cut out the nonsense. So like if I go to a website, I have to do click on this and this and this to find the product I like. Maybe it can just automatically recommend you, hey, these are it knows that I've been looking for basketball shoes. It just gives me an agent recommend, hey, these are the new basketball shoes that came out, or they're on sale, so they just automatically recommend them. But I don't know if these things, especially OpenAI, when they did their operator demo, showed that they don't fully check out, right? You don't want to give the agent complete automated access. So yeah, these have to be thought about. I haven't thought about them too much in depth. What if we have to train a web agent on some task for which data is scarce? Collect data. I guess the web agents, like I said, taking agentic actions is not really a capability that exists in the web crawl pre-training data for a lot of these models. So if you want to train a web agent on this, I guess you should go collect the data, or collect human demonstrations and figure out some inference time algorithm to learn autonomously. So yeah, I think that's the end of the Q&A. I hope I got to everyone's question. If not, please ask. Thank you for listening. I had a great time talking, I guess. So feel free to reach out if you have any questions. And I think that's it.
Thank you.
Thank you so much, Lawrence. We can conclude the session here.
Okay.
Take care, everyone. Bye.
Thank you.